Hello everyone, my name is Satyendra K.R. I am here to present a seminar on the topic test for significance of large samples. Let us take introduction part. The test of significance show that the difference between the sample mean and the population mean is statistically significant. It means test of significance shows that if there is any difference between sample mean and population mean, a two-sided alternative hypothesis is used when there is no reason to believe that the sample mean can only be higher or lower than a given value. Let us understand this with an example. If a company producing cold drink of 500 ml and we have to take the decision if, if there is 500 ml of cold drink or not, then we use two-tailed test. If there is chance of more than 500 ml cold drink included, then we test single-tailed or single-tailed test, and it is also called right-tailed test. If someone claimed that there is less than 500 ml of cold drink, then left-tailed test will done. If the sample size is more than 30, then the sample is called large sample and the test of significance can done, and it is called test for significance of large samples and also called Z test. Some assumptions for test for significance of large samples is the first one, sample is randomly selected. Sample should randomly selected, and second one, sample is large. It means sample size must be more than 30. And third one, if standard deviation is unknown, we can use sample standard deviation as estimate for sigma standard deviation. And goal, identify a sample result that is significantly different from the claimed value. In this case, is our sample mean is statistically different from the claimed null hypothesis mean. Test of significance for single mean for large samples. If we have a mean x bar of a random sample of size n taken from a normal population with the mean mu naught and variance sigma square, and the first step is set null hypothesis, and it is denoted as h naught is mu is equal to mu naught, and second step is alternative hypothesis. Alternative hypotheses are set as in a three various forms. One is a two-tailed test, and second one is a right-tailed test, and third one is a left-tailed test. First we see a two-tailed test, and alternative hypothesis is denoted as h1. In two-tailed test, mu is not equal to mu naught, and in case of B or right-tailed test, h1 is equal to mu is greater than mu naught, and in third case, h1 is mu is lesser than mu naught. It is called as left-tailed test. And the third point, the test statistic or the formula z equal to x bar minus mu naught by sigma by under root n. And if and fourth point, if sigma is unknown, it can be replaced by sample variance S. When the population standard deviation is unknown, it can be replaced by a sample variance S. Then formula is Z is equal to x bar minus mu naught, here mu naught by S by under root of n. After putting formula, find table value of Z, and it is called alpha, Z alpha. As we know, as we are going to a problem, we can understand what is alpha. When there is a significance level is given, then we should and third step is the test statistic formula, and formula is Z equal to x bar minus mu naught by sigma by under root n. And formula is changed. If sigma is unknown, it can be replaced by sample variance S. Then formula will change. Z is equal to x bar minus mu naught divided by S by under root of n. After formulating the problem, we should find the table value of Z or Z alpha as per level of significance given in problem. Then make a conclusion by comparing calculated value of Z and tabular value of Z or Z alpha. Let us move to one problem. A sample of 400 boys is found to have a mean height of 67.47. Can it reasonably be regarded as a sample from a large population with mean height 67.39 and standard deviation 1.30? Test at 5% significance. Solution: given that n is equal to 400, sample mean or x bar is equal to 67.47, mu naught or population mean is equal to 67.39, population standard deviation or sigma is equal to 1.30. Let us set null hypothesis. Let null hypothesis H naught is mu is equal to 67.39. It means mu nothing but mean sample mean of 67.47 is equal to 67.39, nothing but population mean. Alternative hypothesis H1, mu is not equal to mu1 or mu is not equal to 67.39, and it is two-tailed test. Since population variance is known and sample is large sample, the test statistic Z is equal to x bar minus mu naught by sigma by under root n. And let's apply this problem to formula, the test statistic. Here x bar is equal to 67.47, mu naught is equal to 67.39, and sigma is equal to standard deviation of is equal to 1.30 and n is equal to 400. After applying all these and calculating, we get answer of 1.23, and it is called as Z calculated. After this, we should get Z alpha or tabular Z. As per this problem, test at 5% significance. Most of the time, 5% significance is asked. If there is a 1% of significance, also ask, or a 10% of significance, also ask. If there nothing asked, it is default 5% significance. As per the tabular value of Z alpha or two-tailed test, it is two-tailed test, no? So Z alpha or two-tailed test 5% loss is 1.96. We can get it in a table. Since calculated value of Z is less than table value of Z alpha, Z calculated is 1.23 and Z alpha is 1.96. So Z calculated is less than 1.96. It means 1.23. So whenever is Z calculated is less than Z alpha, then null hypothesis is accepted. As per here, accept null hypothesis. Then we conclude that the given sample with mean height 67.47 can be regarded to have been taken from a population with mean height 67.39 and SD 1.30 at 5% loss. It means mu1 is equal to mu0. It means sample mean and population mean is same. There is no significant difference. And thank you.